I can clip that out if
I'm just kidding. No,
needed.
no, no, no. It's all good. I didn't like put on makeup today. And so I'm totally joking.
Wait, interesting. Do you still see the screen share?
I see your
No,
face.
see my face.
I have never seen a screen share.
You've never seen a screen share.
Yes, yet this call. There we go. Hey. Oh
Yeah.
yeah, no, I
Okay.
did see the screen share. Yeah, with the
Okay.
man, my
Cool.
brain this morning.
Hey, Vix.
Oh, Alex.
The Zoom app on Linux has a 1 pixel drag handle for the resize. Yeah, it's impossible.
All right. I'm deputizing a few co-hosts here.
Hey, everybody.
Okay.
Morning, Peter. Brooke, should I admit people as they come in, or are you checking against a list or something?
All are welcome.
No, yeah.
All right, cool.
Let them in. I had a problem on a call that I was giving a presentation on in August, where somebody showed up with the same name as one of the admins and started screen sharing things they shouldn't have because they got deputized along the way. So that was maybe not ideal.
I've heard of that happening. That is the very first call I've ever seen it live happen. I couldn't believe it.
Yeah.
By the way, I also saw on that call, I don't know if for me, I was starstruck, but Diffie, Whitfield Diffie was on that call. So I don't
Yeah.
know. Was anybody else starstruck?
I was like, wait, that can't be. And I looked, I was like,
Right.
oh yeah, that's definitely him. Yeah, this is a Diffie of Diffie-Hellman fame was on this call.
What was the call?
It was the DWeb community, like online call. So when I did DWeb Camp on Salt Spring in early August, I gave a presentation. They asked if I could give that again, just about local first.
Cool.
Yeah.
Yeah, we had Alan Kay randomly pop into a lab meeting the other day, and that was definitely a moment. It's like, oh, hello. That's Elliot.
Hi, Elliot.
It's cool being in an era where like the giants are still among us, you know? It's like if you're into physics, you're never going to get to meet Newton or Einstein or any of these guys, but like if you hang around computer science, you know, so many of the people who started the field are still out there doing stuff, and I think that's really cool. I always tell people these are the early days for us, you know, like everybody, there's this attitude sometimes you hear that like, oh, we missed the beginning and now everything's sort of settled, and I don't think that's true at all. I think we're all lucky enough to be here for the start of a field that will stretch for centuries.
And at the same time, I feel like those are just names that belong in books. So that's why I was so caught off guard to like be in a live video.
Yeah.
Yeah. Okay, we still have some people filtering in. We'll get started at latest at 5 past the hour here. I think it's starting to slow. We have 36, 38 signups as of earlier this morning. So we have 19 right now. So about half the people that signed up have shown up.
I will post the Zoom link in the Discord as well in case it hasn't
Thanks.
been.
I'm just doing that now.
Oh, okay, I will leave it to you then.
All right, let's get started. And more people may show up along the way. It's totally fine. This is also all recorded, and we will post the video later. So, thanks everyone for coming to the second Automerge community call, or as I've been calling this, the Pumpkin Spice Edition. Very cozy out here in the Northern Hemisphere. And yeah, okay, good, it does work. So we have on the agenda today, we're going to do a bit of intros and general welcome. Then we're going to get on to talks. We have 4 talks today. We originally had, I think, 6. 2 of them have pushed out till October, which is totally great because that gives us more time. When we were going over the schedule, it's like, this is going to be tight. So 4 is actually really great. And then we're going to follow that up with open discussion, anything people want to chat about. If you do have a burning question or something that you want to open as a topic for the agenda, please throw it in the chat, and PVH is going to queue you up for after the talks. So our 4 speakers today are broken up into 2 sections. First, we have some updates about the core libraries. These are going to be sort of shorter updates on what we've been working on, and then some actual demos where you can see some actual applications. So the first up will be Alex, who's going to talk about everything new in Automerge and Automerge repo. I'm going to talk a little bit about scaling sync with subduction. This is work that's very much in flight. You can see the code, but I would not use it yet. John Mumm is going to talk about a Keyhive demo that he's been working on, so you can actually see it with some UI behind it. And Chi will talk about Solid.js with Automerge. So this is Solid.js, the library, not Tim Berners-Lee's decentralized storage backend idea. And so, without further ado, I'll hand it over to Alex.
All right, let me try and share my screen on Linux. Can you see this?
Yep.
Okay, good. All right,
Yes.
this is good. This is going to be really quick because it's just a quick overview of things that have changed. So big things that are new in Automerge. Some of these are things I'm planning to merge and actually release today, but this is a 10x faster Automerge diff. So this is a bunch of work Orion did on. We had a bunch of different code paths that diff different versions of an Automerge document in different places. So a diff is a sequence of patches that will get one version of a document to another version of the document in the materialized view. So not the underlying set of operations, but the version, the POJO that you're using in your application. There'll be some patches that will move it to different places in the document history. And that could be slow in some cases. This is actually a regression since Automerge 2 because we now keep a lot of stuff in this run length encoded columnar storage, which we then inflate things out of when we need it. So memory usage has gone down by 100x, but we still have a bunch of work to do to get back some of the performance of Automerge 2. And this diff was one of the places where it regressed a little bit. So this is 10x faster now than it was at the beginning of Automerge 3. It's not quite as fast as Automerge 2, but it's very nearly there, and it's more consistent, and it's a single code path, so it's easier to maintain. And we should be able to eke a bit more performance out there. I think we should get back to 2.0 numbers. And then another thing we've been working on is this bundle format PR. So this, at the moment, when you save an Automerge document, you have 2 options. You compact the entire thing into one giant blob, or you save out each individual commit in the document, or change is what we call it in the API. And this bundle format is a way of saying this set of changes identified by hash, put them all in a single bundle. So we benefit from the run length encoding that you get in the document storage format, but you don't have to encode the whole thing. This is probably generally useful, which is why we've made it available as an API, but the intended use of this is for the sedimentary work that Brook is doing. So you'll hear a lot more about how that's used in a bit, but it's a fairly general building block. You can use it for other things. And then this share config thing, which I've put in quotes because it's an experimental API that we probably won't keep as it is. But if you've ever used Automerge repos share policy, you know there's this way of configuring what documents will be shared with others. But this is actually not. It seems like
Bad. I wrote it, and so I'll say that it's bad. You don't have to dance around it, Alex. I apologize.
Yeah, okay, but the specific way in which it is bad is that it suggests that if this function, which takes a document ID and a peer ID, returns false, that you won't be granting access to that document to anyone. But what it actually does is just determine whether or not we will announce this document to people. So when a document is created, if the share policy returns true, we'll announce it to the people we're connected to, and if not, we won't. But if someone directly requests that document ID, we will always give it to them. So as part of the work on the Keyhive demo that we're doing, we're introducing this share config thing, which, as well as having an announce key, and it also has this access key, which is the same kind of function signature. It's a function from peer ID and document ID to a Boolean. But if that returns false, we won't even respond to requests. This is probably not the API we're going to use long term, but if you want to play with it or use it for, I know there are people already doing things like wrapping network adapters in order to deny access to a document. This might be an easier way to achieve that. But don't expect this API to stick around. We'll probably change it. All right, and then there's a bunch of experimental work on Keyhive, which you'll see the fruits of in a little bit. But probably the biggest thing is that there is this Keyhive package. Again, it's a pre-alpha package. It says that in the release. Like it doesn't even have a proper release number yet. So you'll have to explicitly depend on the alpha.x or whatever it is. But you can play with it. It's a WASM-based thing, which means it can break in all sorts of exciting ways related to your package manager. But this is what we're currently using to build our own demos around. And likewise, some middleware for the network adapters in Automerge repo that uses this thing. All very experimental work in progress stuff. All right, and so what's next? What's cooking? Probably these are all of the work that we're doing right now is in service of getting Keyhive shipped, by which we mean something that you can use in Automerge repo without really thinking about it. And the next thing on that punch list is these kind of three things here. So authors and change visibility is so what Keyhive gives you is it gives you a bunch of ranges of the Automerge commit graph that different people are allowed to write to based on whether they've been granted or revoked access to the document. And the way we plan to use this in Automerge is you feed those ranges of the commit graph into the Automerge document, and then Automerge only materializes the changes that are authorized. And like a specific example of why this might be useful is, say I've given Alice access to a document and she's written a bunch of stuff, and then I revoke her access and she concurrently wrote a bunch of stuff and sent it to Bob. When Bob receives the revocation from me, he wants to update the state of his document to be as if Alice had not made those changes. And so that's what would happen here, is that the Keyhive would receive the revocation and go, oh, okay, the relevant ranges of the commit graph have changed to X, pass them into the document, and then the document changes its materialized view. So the idea is that we're not actually removing the underlying changes, we're just changing whether or not they're considered visible, which allows us to cope with things like revocation cycles or concurrent edits while revocations are made. So that's an API that we need in Automerge, but it's actually, again, somewhat general. This is not specific to Keyhive. It's basically saying that every change will have a tag on it that's the author, which is some arbitrary bytes. And you'll be able to say these parts of the commit graph I want to be visible for this reason, for these authors. And so you can use that to implement things that are not Keyhive based if you want. And then on the Automerge repo integration side of things, there's integrating with Sedimentary, which Brooke will tell you more about. And then we've already got Keyhive somewhat working in Automerge repo. The next step is probably to get encryption working. So the Keyhive is just doing access control of the network boundary at this point. Next step will be actually encrypting it. So even if you have the bytes, you can't read them if you don't have read access. Yeah, there we go.
Awesome. Should we do questions at the end, or?
I didn't see any questions in the chat,
Okay.
but let's pause for a sec. I think because there's going to be a lot of technical stuff, it's good to have a little breather here. So if anybody has questions about new Automerge things, you can chuck them in the chat. If you have feature requests, you can chuck them in the Discord anytime. But if you put them in the chat, we're more likely to forget them. So at least mirror them to the Discord for later. Rob has been using the announce policy in Samod, which is working well.
The announce policy in Samod is currently has the same limitations as Automerge repo, but I'm gonna like basically Samod is pretty much a port of Automerge repo to Rust, so I'm not going for new semantics there, but I'll probably port the same share config in because I want to be able to use keyhive from Samod. So
Shu is asking a great question, which is what happens if revoked changes have been depended on by later legal changes? And the answer is they go away too. You lose anything that is, downstream of those changes.
You do not
lose,
lose the downstream. Yeah.
lose, to be clear, just means they're not
Yeah.
materialized. They're still
Right.
you
They're-
still have
they're-
the data.
Sorry, they become non-visible. In Automerge, fundamentally, you cannot apply changes that don't have their predecessors. That is a change. We believe it should be someday possible to relax that restriction, but all of Martin Kleppmann's clever proofs about whether this whole thing hangs together rely on the assumption that, if B depends on A, then if you don't have A, you don't have B. But it may be possible to improve upon that or relax that. But we want to be very careful not to break all of your applications and permanently corrupt your data. So this is a safe place to start.
Yeah.
Okay, thanks.
Yeah. So we basically turn them from visible to invisible. They're still in the document. We won't connect to somebody that's been revoked, but if you concurrently accepted some changes and wrote a bunch of stuff on top of it, and you can connect to us, we'll still accept those changes. We just won't materialize them.
Great.
Yeah, and I think this visibility design has potential for use in other areas as well. I've thought a bit about whether we could extend this to do moderation. I also think it has potential for use in sort of doing branches. We have a lot of this is a nice general purpose capability that will have a lot of hopefully long-term applications. Do your changes depend on someone else's if you just type some text after seeing their changes? Yes. Alas, that you do. This is a limitation of the system for now.
All right, I'm just being mindful of the time. I'm going to keep rolling here. Let's see if I can share my screen again. Why don't I see Keynote in the share options? That's not great. You would think that as the owner of the, but it's not showing up at all. That's awesome. There we go. Okay. It took it a second to find it. All right. Does everybody see Alex in Berlin? Yes, great. So if you want a deeper understanding of the internals of sedimentary, you can see Alex's talk from earlier this year, from a couple months ago. We're now doing the actual implementation of it, or there's a proof of concept. Now we're doing the actual productionizable version of it. So this is going to be, in order to leave time for the actual demos, a quick, mostly accurate, slightly hand-wavy crash course in subduction, which is scalable sync for hash-linked data. This isn't the actual logo. This is just something I threw together for fun. So we're trying to solve a bunch of problems with the system. One of them is, or the main one is scalability, both on how much we need to keep per node, how much we need to keep in memory per node, how much CPU we need to use to serve a request, and then also we want to be able to scale things out horizontally. So an example that we talk about a fair bit while working on this project is, what if I had a set of workers? So I want to use Lambda or Cloudflare workers or something like that, and I want to scale out serving requests. So we can still have a regular normal sync server that should scale much better using the system, but we should also be able to horizontally scale out. A problem that you'll hear me talk about a few times in this talk right now is, in the current system, we have, it's connection oriented and it's stateful. So you can't switch between nodes at all. Nobody else can serve it. It has to go to that specific node of memory, regardless of how they're backing it in storage. With something like a bunch of workers, we could store all the information, all the actual, Automerge changes in, say, a shared S3 store or R2 if you're on Cloudflare, and serve them out of there. But we can't do that in the current system because it requires all of the state per connection. So regular sync, how does this stuff work today? And the convention I'm going to use, because someone's going to get confused no matter which way I point the arrows, is you have parent on the left and children on the right. And the arrow is not time, it's what it depends on. So we're talking about the dependencies with Keyhive. This is also the dependency arrow in all of these graphs. So here's some graph of Automerge. We have a bunch of commits, and I want to sync them. And I have another peer has this stuff that's in that more fuchsia color, in addition to some shared state. How do we actually want to get that across? Well, we ask for, hey, what are your heads? And the head could be the same one as we have. It could be something halfway through. It could be something completely disconnected that we've never seen before, right? And we have to be able to handle all of these cases. So in order to do this, when we materialize a document, we have to load the entire document into memory. We hash the entire thing and produce a table of hashes to their position using the vector clock for the position in the materialized document. This is a ton of hashing. So if you have, say, 2 million changes in a document, you've got to do 2 million hashes on load. And that's about 4 megs of just the hashes, to say nothing of the other data, metadata that we maintain for this. So that's a lot of hashing, a lot of stuff in memory per document. And then we also have to maintain the sync state of what we thought the last time we connected to you, what we thought you had. So that's sync state per connection. And these connections have a problem where they can get stuck. So they have to process messages in order. And if the other end is slow or busy, or on a bad connection, you can get out of sync with this stateful connection. So none of those are really great situations to be in. Alex was saying earlier on a call that this is the #1 cause of bugs in the current sync system, right? So it's not a good situation to be in. Plus, we have to scale this up. So we don't have just one document. We have, on the current sync server, something like 200,000 documents, times 4 megs a piece. You can see how we run into memory limits pretty fast here. So that's also not super ideal. And we have a new problem coming up with Keyhive, which is the current system expects you to be able to materialize the entire internal state of the document and see everything on the inside. And we're about to lock that away with end-to-end encryption, like in the next couple of weeks here. So we need to have another mechanism that doesn't depend on understanding everything about the internals of Automerge. The additional bonus of this is if we don't depend on the internals of Automerge, we don't depend on Automerge at all anymore. And actually, this is a reusable system. So we are building this very much for Automerge, but somebody else could pick it up and say, hey, I also have a hash linked thing. Please sync it for me. There's some trade-off in this design space between really granular changes and really coarse changes. For fine-grained, small changes, it's very precise. You never overfetch data. It's very nice for bandwidth. You get a lot of control over what you sync. And it's very efficient for small diffs. So if I'm doing individual keystrokes, that's efficient. I don't have to send the entire document every time. Coarse-grained is much faster if you want to catch up really fast. Like I've been offline for a week and I just want to get the latest stuff. You do less work in memory because just at one extreme, it's just like, here's the entire document. I'm just going to grab it out of storage and here you go, and throw it over the wire. Less IO and less compute because we're not calculating, or we're calculating fewer diffs because it's bigger chunks, fewer, the graph is smaller. But each of them have the exact opposite trade-off, right? Fine-grained things are inefficient for catch-ups. They use way more memory. They use, they've got to go into storage more often, and you have to compute more to figure out the diff. And in coarse-grained, you may overfetch, so it's less nice on bandwidth. And it's inefficient if you're doing, individual live collaboration. So we need to have some way of adjusting based on use case. And we want to do this in a way that ahead of time, we can decide, without having to know per request, we want to do at write time, at storage time, hey, this stuff is probably going to be needed fast and should be small. And this other stuff, hey, this is more like the old history, and I want this to be large and coarser. So we need to be able to handle both live and batch sync efficiently and find some balance between these two. And the way we've done this is we've found a way of doing chunking based on hashes. Probabilistically, hashes will usually not end in a 0. And the more zeros you have, the larger a chunk that'll produce. And those are stable because we are using, we're using the hashes. If I hash it or you hash it, we have the same thing. So we have a consistent metric for knowing how to slice up a document based on how big we want a particular range to be. So in this case, I'm going to start at my head and I say, oh, this one has no trailing zeros. Right, there's none of them. This one also, no trailing zeros, no trailing zeros. Hey, this one has 2 trailing zeros. Cool. Where should my next chunk start? So I need to find the next one with at least 2 trailing zeros, where there's one here and there's one here that has 4. So now I can slice these up like so and make these different sizes of chunk. I can then forget most of the internal structure. It's not big enough to show. We actually do keep anything with trailing zeros on it, but we forget most of that internal structure and kind of simplify this graph. So there's much less information now being kept in memory and for us to need to sync around. It's very fine-grained for, again, probabilistically, much more fine-grained near the head, and bigger as we go towards the back, because it's more likely that we'll have more zeros. That'll take everything from that point to the beginning. So if I clean up this graph a little bit, the reason that this is called sedimentary, which is a pun between sedimentary things, like layers in rock and a tree structure, is we take those number of zeros and we can then say, hey, here's my different layers of changes, of chunks. And as these fine-grained things eventually hit new boundaries, we can re-chunk them and move them down a layer in the sediments. So add them lower in depth. Probabilistically, again, we get a certain size. I'm lying a little bit here to make it easy with the hashes. We actually do this in base 10, but in hex, this becomes 256 commits per chunk in this depth 2, and about 65,000 in depth 4, which means that we're keeping around a lot less information about the graph. Before, in this example, we have about 66,000 commits that we're syncing around, and now we have about 6. So calculating the diff on that is much more tractable. It's much faster. And things that are older, so things from say last year, we don't need them in super granular form. We know that if you're missing that, we can probably just send you the entire document or like half the document at a time. You're probably not asking for change 2. You want that whole section, right? Because you want to catch up really fast. And then actually doing the round trips, there is a way of cutting this down by 1 direction, so we can make this 1.5, but it scales less well. So we've decided to go with this 2 round trip version. We can always sync 2 peers in 2 round trips, and eventually, if we want to extend the protocol, we can sync n peers in n trips always. So here's a requester, and let's call it a sync server here, the magician, and all they say is, hey, send me your view, your metadata, not the actual content, for sedimentary number 123. And sends, oh yeah, I'm not going to do any compute. I'm going to grab this thing out of storage and just send it to you. I do no work at all as the sync server. And that's just that sketch again. Then the client can compute the diff based on what they have and say, oh, hey, here's my diff on that sedimentary. And I know that you're missing these blobs, right? Some chunks of changes. just dump these in storage directly. Sync server goes, okay, cool, got these, dump those in storage. I've done basically no work. And based on the change diff that you said you had, there's that little red section there. This is the blob you need. And now we're up to date and we're done. We're doing this today over WebSockets, but this is, you may notice, totally doable over, say, HTTP as well. So we might not even have to maintain WebSocket connections, and they can be a little bit flaky. We can just do 2 round trips. And if you're interested in seeing how the code's coming along, do not use this today. But I flipped it to public yesterday. You can watch me wrapping it for WASM the rest of this week. Great.
Any questions? I'll be the Q&A guy. It's like being a reply guy, but backwards. End peers in end round trips, like total?
Yep.
One other thing that you can look forward to with this, which is, hashtag coming soon, is Brooke was talking about syncing a single document, but we can actually put the collection of all the documents that you want into a similar structure and get you caught up on lots of documents at the same time, or at least figure out what set of documents you need to get caught up on. Whereas right now, though we don't create a separate WebSocket for it, when I open up my patchwork, which has 6,000 documents in the sidebar, it has to send a separate message for each one saying, hey, is there any update for this? And that's becoming tedious.
Yeah. There's a broader system that Alex had worked on earlier this year called Belay that is really, really fast at doing many, many documents and can figure out which documents you're missing. We are going to do multi-doc sync, but it's much simpler now just to ship it in chunks. So PVH is 100% right. We're going to say, hey, here's the docs I'm interested in, and then they'll send you whichever ones it happens to have back. And we can pack those in a lot of cases in our early experiments, especially this first round trip. We can pack several of those into a single packet. These are very, very small metadata to move around. And also, just to clarify, the n round trips for n peers, that's in a cluster. So that's not pairwise syncing. Each pair that you would sync on, that's considered separate. But if you had a cluster and they were all gossiping together, you could do them in 3 of them would be in 3 round trips. 10 would be in 10 round trips. Great.
All right, great. I think you should move on, and I'll
Yeah.
keep an eye for any more comments in the chat.
Awesome. Great. John, you're up.
Oh, sorry. Just trying to figure out the share thing. 1 second.
We see your screen.
Okay, great. And do you see me changing into different browsers?
Yes.
Cool. Okay. So my demo is going to be a pretty quick look at how you might use Keyhive to manage access control if you want to be sharing documents. So that's, of course, one thing right now with Automerge and Patchwork, for example. If someone has the link, they have access to it. So if you want to have more like fine-grained secure management, Keyhive is going to be part of that key part of that story. So I'm going to try to illustrate a bit of what that functionality might look like. So we imagine that both of these browsers are different user accounts, could be on different machines, could be on different browsers or whatever. We have this one over here, and each of them has a contact card, which is what we're going to use to actually share a document with someone. So we'll use this contact card as sort of their unique ID. So we've got this user over here. This user has another contact card. Imagine that we create a new document. We just add some data, whatever, and we want to give access to this user over here. So we'll copy that contact card and we'll click on the share button. So here we've got some options. When we're going to share with someone, we could pop in that contact card and decide, okay, what kind of access do we want to give them? Pull means that they could only grab the bytes but can't actually look at the contents. Read would mean you can read it but can't edit. Write, you can edit. Admin means you can do all of that but also revoke. And one of the things that is true of Keyhive is that you can then also share at your level or below, and I'll show you what that will look like in this UI. So imagine that we just give pull access to Alice here, and then over in Alice's world, we pull in this document. So right now, we don't have access. Now right here, we're seeing the title, which is something that wouldn't actually be leaked in the final system, but at least we're not seeing the context of the document. And if we want to give more access, then say we, actually, I got to grab the contact card again. So let's give her write access now. Sorry. All right, let me try again. We'll just give a write access to the new doc. Something quirky is going on here.
Do you need to copy the contact card again? You missed a close brace, says big mistake.
Oh, okay, that could be the problem, yeah. All right, let's start up a new one here. Sorry. Live demo fun. Okay, there we go. So now if she pulls in this document, she now has the write access, and we can see that reflected over here in the original. And now she can share, but only at this level or below. And you see here right now, we've got now these three people with access. We've got Orpheus, who created the document and is admin. We've got Alice, who has write. The sync server itself only needs pull, because it's just going to be pulling the bytes, and when they're encrypted, it's not going to be able to look at the contents of those bytes once we have encryption for Keyhive. And notice that Alice can't revoke anyone because she doesn't have admin, but Orpheus over here does have admin, and so could revoke Alice as we did before, or revoke the sync server, which in the case of this demo would be a bad idea. And that's about it for this demo. So, maybe this could be a good opportunity for people to ask questions, but it was just meant to give a sense of what you might actually be able to do in terms of sharing with Keyhive under the hood. So yeah, so happy to field any questions.
We'll give people a moment to think and type before we move on.
One thing that might be worth noting is that this is an Automerge repo app. It's built on top of a bunch of extra bits and pieces we're building to plug into Automerge repo, but this is Automerge repo, so we're not we're hoping to kind of keep most of the same API.
Dima would like to know if access can be granted transitively. Could you make a document? Could you make a group for your team and have people in it? Could you put docs in a folder and have that share?
Yeah, definitely. So not in this demo, but definitely that's part of the design around Keyhive. So Keyhive does support that already. It's just not surfaced in this demo. So document itself is kind of a group that you're adding folks to, and you can add a group to a document, and that group could contain other groups and so on and so forth.
Yeah, one way of thinking about that, we're drawing obviously a lot of design inspiration here from, Google Docs and GitHub, access control, all of this stuff, right? And in Google Docs and Dropbox and these systems, if you grant somebody access to a, say, directory, they have access to everything underneath that. And Keyhive is a way of wiring that all up under the hood. And then same thing for groups. You can create groups, basically saying like, here's everyone who's in a group, and then maybe groups also contain other groups, and then you can connect them to particular resources. Yeah.
Can roles be arbitrarily defined, not limited to admin, write, read, pull?
So
Well,
no, yeah, sorry, go for it.
Oh yeah, so I was going to say that currently in Keyhive, those are the roles. That there may be things at an application level you could do on top of that, but right now Keyhive itself
Yeah.
wouldn't be able to force that.
Adrian, can you clarify your question? I mean, from a document perspective, those are the things you can do, which is, you can pull the document, you can read the document, things will accept your rights, or you're allowed to add and remove other people. What do you mean by arbitrarily defined? What's that? Well, maybe we can continue that conversation in the chat. I would love to have that chat. And if it spills over into the Discord, I'm always delighted to get further input. Dima would like to know if they can reuse a Keyhive structure to give application-defined roles to group members.
So I would say similar question to, or clarifying question to the one prior. What specific application defined roles are you
I
looking
think
for?
I might be able to respond to this, which is that the way we think about the world in Automerge is very data-centric. So if you have access to data, then you can do things or know things. And so a role in sort of my understanding of an application comes down to like, what can I see? What can I edit? And that applications are built up on top of those. So like if there's a list of conference rooms and you are not a whatever building facilities person, then you can't edit the list of conference rooms, but you should probably be able to see it so you could book a meeting. If I create a memo about, a corporate policy, and then I set the HR people to be able to write to it, but everybody else can read, right? Sort of at the application level, this is a building block that you can use to decide what different kinds of users can do. And so you can build up a sort of a role in the sense that you're uh, binning certain sets of permissions over certain sets of documents to different kinds of people, and then people's accounts can be put into those groups. And so, an account can be in lots of groups, and there can be lots of groups in an account, and documents can be in lots of groups with different permissions and so on. So we think it should be flexible enough to model anything you want to model. And once you get your hands on it, please take it for a spin. And if you can't figure out how to hold it, we'll write more docs and create more examples. But I'm pretty sure you'll be able to do what you want to do with it. So please, yeah, if you're confused when it's available, get in touch, ask questions, and we'll try and get it going.
Yeah, maybe just one bit of color on that. So you can create arbitrary hierarchies of these. So if you want to have different kinds of admins, so you have, whatever, staff, and then management, and then upper management, and then, the board, right? You can absolutely do that. And then, the board can always revoke, whoever, managers, right? But giving them more control and more application specific things, the system isn't aware of those yet. We have had a couple requests for, or at least queries on if we could make it do subdocuments. And we have looked at that. A few other similar systems do this, including ones that I've worked on in the past. But right now we're very much optimizing for small and simplest possible thing that we can ship. And we've thought about ways of actually working around those limitations without adding new code. So we'll see how people actually go and use them first, but definitely interested in hearing about people's use cases, both here in the chat or ideally over in Discord, so we can have a longer discussion after. And then, yeah, just because it's been a question in several threads, so I don't have to answer it in several places. Contact cards. What is a contact card? It is your public key, so how you sign things, and the information needed to encrypt things for you. So it's a ED25519 key and an X25519 key, public keys, and that's it. Cool.
There's more questions coming in the chat, and I'm gonna sort of say, like, we'll field them in the chat. Please keep asking questions, but I think we can move
on. She.
Hello.
Hi.
Wish me luck. I'm going to try and share a screen for the first time since installing Zoom. So,
Okay.
how it goes. What are we we're seeing things?
Yes, we're seeing
Yeah.
your entire screen.
Excellent. Interestingly, I have a pop-up here that says Zoom is requesting to bypass the system window picker. It's asking if Zoom should be allowed to share my screen, yet Zoom has already snuck in and shared the screen. Okay, cool. So yeah, I'm assuming here that, so I'm going to be talking about Automerge repo solid primitives, which is some solid sort of hooks for Automerge specifically, Automerge repo specifically. And I'm going to assume that everyone here sort of understands what Automerge repo is and has used a UI framework such as React in the past. These are my assumptions. Speak now or forever hold your peace. Excellent. So there's the sort of desire to do this. There's lots of things that something like React is very good at, and lots of things that are pretty good. And there's lots of things that like Solid.js is extremely good at, and there's a lot of overlap in those two groups. But one of the places where Solid like really shines is if you have a data structure that communicates how it changes in precise fine-grained updates, and you want to update a retained mode UI while minimizing wasted work. For example, if you were trying to create a high performance, highly collaborative environment for creative work backed by Automerge, running in a web browser, this would be a great tool for that. An Automerge repo solid primitives is like a little bit of glue to make that bridge between an Automerge, between a Solid.js store, which is like a deep signal or a ref in Vue, and keep that up to date with an Automerge document. The README is here, and it goes into some detail. I was going to paste it in the chat, but I don't have access to the chat. And you can see it there up at the top. What I was going to do was quickly go through what it would look like to take an existing Solid.js app like this and convert it to be an Automerge repo solid primitives app. So this is as a little side note, does anyone know of like a collection of graffiti resistant demo ideas that you can use to show off like dynamic and collaborative environments, but without people worrying about people drawing Nazi fish? Is that something that's written down somewhere? I know that Netlify one time did this one where it was like you could generate a blob and then press upload, and this was the entire thing. It's a blob with a number of sides and a seed, and that's the entire thing, because this was all they could do for interactivity. It seems like something that would be good to have a collection of, because I don't know, I run into this quite a lot. But this is an application that allows you to create colored dots by clicking on dots. And this is it as a standard sort of Solid.js app. So we create a store that has all the pixels in it, and then we create a grid. And when you click it, we update the grid store with this little producer function. And so I'm just gonna, this is the code that you have that you would write if you were a normal Solid.js developer. And I'm gonna quickly pop in what you would change in order to make this Automerge repo friendly. So we have our import map here, which is already set up to import Automerge vanilla.js and the repo solid primitives. And this delightful CSS style sheet here, making the grid work. The first thing we need to do is import our use document. So that's as mentioned in the repo. We also need to perform an incantation to get Automerge working in this sort of bundleless environment. I'm just going to paste that here because I don't want to try and type it. It's this. And then down here where we're creating this grid store, I'm going to make a Automerge document containing the grid instead. I'm going to just comment that out, otherwise I'll be making a knocking over this thing server. And we're going to change this. That got me my Automerge URL, which is now in my clipboard. And change this to be used document and pass in our URL. And then here where we have our grid being used, we're going to call it as a function, which is just sort of going to let this function know, this component know that it needs to register like reactive awareness of this grid store. When Solid.js 2 comes out, we can probably make this not be a function call, but that's for later. We're going to change this one to do the same thing. And where we have update grid produce here, we're going to change that to handle.change. And happy? Yay. And we're done. So that is now just gonna hit stop share there. That is now a little Automerge document. You can also hop in and enjoy yourself if you want. You can go in and click the buttons. You can also change the code because the text editor I'm using there is also a solid Automerge app. So that's all available to edit and click all you like to your heart's content. Yeah, I think this is that Automerge is the first like CRDT, or even really the first proper local first, mature local first library that has first class solid support. So pretty good. It is the best way to build web applications.
Yeah, bold claim. Citation needed, but I like it.
Amazing. Questions from the chat?
I see hearts growing in the chat and smiley faces on Cheese app. Love the simple demo. I apologize for the initialize wasm call, everybody. Red is not defined. Someone broke it. Collaborative programming, everybody. One of the ongoing research areas at InKnSwitch is how to have version control primitives that allow people to collaborate safely over the internet.
How hard could it possibly be?
How hard could it possibly be? Any questions? I think that pretty much was like delightfully straightforward and obvious, Chi, as I don't see too many things to ask. Is it fast, Chi?
Yes.
Is it efficient?
Yes.
Is it complete? Is there more to come?
There are some things that would be nice that every time I build an application with it, I have to do by hand, but they would involve hammock time, as we like to say. There's definitely a create store if there isn't one already. That would be nice as a primitive, but then you need to make then you're starting to make decisions about where the information is kept for people that you probably want to keep at an application level. But it would be nice to have that as a, you want to just sort of go, here is the object I want, like the bit where I commented out the creation of that document. When you're creating a document, you're either getting one or creating one. There's a lot of times where you just sort of want to be able to write that once and not think about it, but that's
cool.
like, I think that
Great.
Jazz has a nice thing for that, where you just sort of go co-state, right? Just give me a piece of state that looks like this, and it will either be the one that you just made or another one that you had before. That's kind of nice.
Awesome. Well, I think, is that the end of the demos, Brooke? Any more questions in the chat? I don't see any, so we can move on.
All right.
Yeah.
We are basically right on time because that was our program for the day. So we have a few minutes here before the top of the hour. People want to hang out for a bit. We have some links at the top of the page there. Next session here is October 22nd. We already have 2 people signed up to demo. We probably have space for about 1 more if you really want to show something off. And yeah, thanks very much, Chi and John, for live demoing today. Always nerve-wracking. The demo gods bite all of us. I'm not sure if any of you saw Zuck get hit with the demo gods Wi-Fi earlier this week, or I guess last week. Happens to all of us, missing a brace, etc. So great. Any questions folks have, especially about the things that we talked about today? This is a good time while you have us live. Otherwise, take things into Discord. Yes, we need to get everybody yellow outfits.
Can we get Automerge hats? Like a top hat, maybe.
Is that how we sync heads? Wait, no. Okay, this is just gonna be me making bad puns. I'll give people the last 4 minutes back here. I'll post the video when it's available later today after Zoom does whatever processing it does. Thank you everyone for showing up, and we'll see you all over in Discord.